Hello again, this is Keith Davis at KLJ Instruments. In the previous two videos we have looked at Mode S targets that are stationary surface targets and a moving airborne target. We have also reviewed a method for creating a flight path with more than 6 waypoints. I have two more topics to cover for Mode S targets in WAM mode. These two topics are Mode S replies and Mode S bit errors. Let's open the SQTR-2M GUI, select the WAM mode, and go to the 1090 Target Setup menu. At the top of the Mode S Targets box are data entry boxes for DF4 PRF, DF5 PRF, and DF11 PRF. These values default to 0 or off, but each may be set to values up to 500. The entered values will apply to all Mode S targets in a scenario. At the bottom of the menu, we can see that each reply type may be enabled or disabled for each target at each waypoint. In addition, the data for each reply can be altered. This alteration is a 4-step process. Step 1, the SQTR-2M fills in each reply with the data it knows. Step 2, for the data fields in a reply that the SQTR-2 does not know, it performs an exclusive OR operation with the data entered and the data bits that the GUI would otherwise default to 0. Step 3, the correct CRC value is calculated and added to the reply. Step 4, the CRC is exclusive OR'd with the last 6 hexadecimal characters of the entered data. An illustration will be helpful. I will start with our last scenario, but I want to simplify it so the data will be easier to see. Next, I will disable all targets except for target 1, which is one of stationary surface targets. I will set the PRFs for the DF4, DF5, and DF11 to 2 per second. Now for target 1, I will disable the squitters and enable all 3 DFs. I will compile this scenario and save it with the file name w-target1dfs. Remember that when a compiled scenario is saved, the GUI also saves log files for each active channel. Now I will open the log file for channel 0, w1targetdfs_0.csv with Notepad. The first 3 rows after the header row show the data for DF4, DF5, and DF11 in hexadecimal format. I will enter that data into my table. Let's take a closer look at this data. I have added 2 rows to also show the data in hexadecimal and binary formats. There are a large number of 0 bits in the DR, IIS, IDS, and ID fields. Now I will enter 8 Fs and 6 zeros for the DF4, DF5, and DF11 data in the GUI. I compile this scenario. This will tell us what fields we are able to change apart from the AP field. Save it as w-target1 dfs data ff. Then open the W-Target1 DFS Data FF log file to examine the new data. Notice that we were able to change the DR, IIS, and IDS data fields. However, since the FS and ID data fields are controlled by the GUI, these did not change. Also note that the GUI calculated a new value for the AP field. Finally, I will demonstrate that the AP field cannot be corrupted by entering Fs for the last 6 characters of the DF4, DF5, and DF11 data. The new log file shows that AP field has not changed. The error masks for the Mode-S squitter operate differently from the DF data fields in 2 important ways. The first difference is that the error mask is exclusive ORed with every data bit, even if those bits are normally controlled by the SQTR-2M GUI. So you may change any or all bits in the data. The second difference is that the AP field can also be changed by the error mask. If you want to change 1 or more data bits, but still have the correct AP data, then the last 6 hexadecimal characters of the error mask must be zeros. On the other hand, if you want to test the CRC decoding function of the receiver under test, you may use the last 6 hexadecimal digits of the error mask to toggle any or all of the CRC bits. You may examine the effect of the error mask by viewing the information in the log files, just as I did with the DF data. This completes the overview of the Mode-S features of the WAM mode. In the next video, we will look at @crabs replies and 1090 interference.